Okay. So today we're going to look at slopes. Now you guys have seen slopes before, obviously. But we're going to look at slopes like you've never seen them before.
Oh no!
Oh,
Yeah.
oh wow! That's so green gone. Gotcha. Not red.
Very good. We're going to look at the slope of a curve now. All right, slope of a curve.
What? How do you look at a curve?
All right, so what makes something a curve? What makes something a curve is that the slope is actually changing the whole time. Because if the slope stayed the same, what would it be?
Right.
It would be a straight line. So a curve means the slope is changing. All right. So let's put a little curve here. So any point on this curve, we can take a point here and we can say, well, what's the slope there? Well, really, technically, it's not the slope of the curve. It's the slope of a tangent line to the curve at that point. Okay. So, but you can do that anywhere on here. So just imagine a bunch of little tangent lines here. Those would be the slopes. We're going to call those the slopes of this curve at any one of those points. All right. So the slope's constantly changing. As this curve is going up, you can tell that all these slopes are going to be what? Positive slopes. Okay. When the curve goes down, those are going to be negative slopes. Anytime right where it turns around, yeah, you're going to have a slope of 0 right where it turns around. Okay. All right. So that's all. Now, slope formula. Your old-fashioned slope formula is what?
Delta y over
y2 minus y1 over x2 minus x1, right? Okay. If you had Miller, you should have that memorized for sure. Okay. Okay. So that's your slope. Now, what do you need in order to use that? You need 2 points. You need 2 points in order to do this. Okay.
Get that with the curve.
Well, we need to figure out how to do this at 1 point. All right? No, it actually will be possible. So let's call this x1, and let's call this x2. All right. If that's x1, that's 2. What does that make this over here? That's y1, and then this over here will be y2. Sorry, this is getting a little messy here. Yeah, the y values just go with those x values, right? Okay. No, don't worry about that. Okay, so we have our 2 points here. We have this point right here, and we have this point right here. Now, if we wanted to get the slope between those points, we could do that with our slope formula. And that slope would, let me get a different color here, purple maybe. If we got the slope between those points, that would give us this straight slope right here. Which actually, the way I drew this, that's pretty close to the slope of the curve in that area. All right. Now, so you can estimate the slope at a point by taking the slope at 2 points. But what would make that estimate more accurate? Shorter length between the x's, right? So if this distance right here was shorter, in other words, the x's were closer together, and you took the slope, the closer you get, you're going to get a more accurate slope, okay, for a slope at the 1 point. So what would give you the most accurate slope would be if these were infinitely close together. And we have a way to work with that now. Okay. So, all right. So I'm going to take you through a couple steps here. Now, what I'm going to do right now, it's not something that you're going to have to do, but it's something that you need to understand. Okay, it's a conceptual thing. As you go forward in your math careers, or whatever math you're going to learn, it's going to get more and more dependent on understanding the concepts, and less important on just following particular steps to do particular problems. Because, like the problems we saw, the hardest part is on that worksheet yesterday. The hardest part is figuring out how to get started on the problems. Okay, So it's the concepts that become more and more important. All right. So I'm going to take you through a little ride here on this curve. Okay. So. Whoa.
I'm ready. I have no idea.
The first thing I want to do, listen, hey, the first thing I want to do is I want to get this out of old school notation and get this into function notation. Okay? So, what's the difference between function notation and regular notation? What's the difference? Yeah, Justin.
Function is f of x.
F of x. What's the f of x? Y, right? Y is f of x. So if I can just rewrite that then, this y2 would just be f of x2, right? Because that's the y that goes with that x. And y1 would just be f of x1. And I'm going to leave my x's, x2 minus x1 here, okay? So all that is changing into function notation, replacing the y with f of x, okay? Now, I don't want x1 and x2 because I want to get this down to 1 point, not 2. I only want one x to have to plug in. I don't want 2 x's, okay? So the way we're going to deal with that is we're going to take this distance between that we're talking about here, this distance right here, okay, we're going to call that h, just because that's what everybody calls it. Alright, we're going to call that h. Alright, so,
H for height.
no.
It's width.
Pretty good, okay. It's like that tweet thing. Okay, so we're going to call that h. Now we can rewrite this. This x1 now, I don't need to call it x1 anymore. I can just call it x. If I just call that x, I'm not going to call this x2. I'm going to call it exactly x plus h. Because to get to here is x. To get to here is x plus h. Okay? This is now x plus h. Now I only have one x, which is nice. That's what we want. Okay? So,
oh my gosh, then do we have to change the top?
right, so now we can take this x and x plus h and put those in for the x1 and x2 here. Alright?
Same thing with the y.
Well, we don't have any more y's
Or
here.
f of x.
Yeah, so exactly, but they're all x now, so we can do that. So, the x2 is what? X plus h. Right? The x1 is just x.
Wait, why is this?
Look over here, this x1 just became x and this x2 became x plus h, okay? And that's all over. This x2 is x plus h, right? This x1 on the bottom here is x. So now look what happens on the bottom there.
God, got awesome x's.
The x's drop out, right? Okay. Now, so I'm going to drop those out for the next step, but I'm also going to, I'll go ahead and do that. So we have f of x plus h minus f of x all over just h now, right? Because the 2x, x minus x drops out. Now, this distance is h, right? We want h to be what?
0.
Well, we want it to be 0, but we can never get it to 0. We want it to be very small, though, right? Because the smaller the h is, that means the closer the x's are together, right? So we want h it can't be 0, but we can get it infinitely close to 0 by using a limit.
Negative infinity? No. No.
Yeah, well, we're talking about the h here, right? We want the h to be 0, but we can't quite get to 0, so we're going to use a limit. The limit as h approaches 0, and then this f of x plus h minus f of x over h. This is a very important little deal here. Okay, it's not really a formula because there's no equals, but
That's a full equation.
yeah. Now this is really the limit definition of the derivative, which we'll get to later. But if you look at this thing here I have in this box, it looks very sort of mathy and everything compared to this original slope formula you guys learned in Algebra 1. But what I want to stress here is that it's the same thing, okay? The y2 minus y1 over x2 minus x1 is to get the slope between 2 points. The limit at h approaches 0 of all this stuff, this is to get the slope at 1 point. but this comes directly from this. So I want you to say, you see something real complicated like this, understand where it comes from, and that's going to help you in the long run. Okay? This and this are really the same thing. Okay? All right. So now let's use this now. Okay? Now you don't ever have to actually go through these steps on a calculus problem. I might ask you in this class to do it just to show it. Okay? To show how you get from the old slope formula to the new slope formula. Okay? I might ask you to do that here, but you never actually have to do that in calculus. You do have to know this. You do have to know this limit form here, though. Okay? So I'm gonna go ahead and rewrite that over here. Let me go back to my blue here. So we got the limit as h approaches 0 of f of x plus h minus f of x all over h. Right?